Welcome to Radio Hound Tube Radio Restoration. This is John from Indiana. We're going to be wrapping up on our schematic series that we've been doing. I'm going to try to pull it all together for you. It's not going to be a be-all end-all. That means we're going to be doing this again. It's just finishing up of the little flyover we did of the schematics and help you feel comfortable when we start recapping our radio, and that'll be coming up real soon. Probably in the next video or two, we'll start actually replacing wiring, replacing parts, and try to get in there and check things as we go. And I'll try to train as I go through there. So I hope you enjoy today's video, and keep your questions and send those in at the end if you have any, and I'll try my best to answer them. I've been trying to stay on top of that. This has been a fun series, and it's helped me learn a few things too. So I hope you enjoy today. Thank you. Well, hello. Welcome to the video this week. I'm going to go over a few things and try to wrap all these videos that I've put into the schematic reading and make sense for you. I'm going to try to start off with the question is, why is it so important for us to learn a little bit and how to read this schematic? Well, the number one thing is the reason we do this and make sure we learn these schematics is troubleshooting. You think about it. The reason you're in this radio in the first place and you're looking at stuff is you're trying to figure out what is wrong, what is messed up in this radio, or is there something messed up? Maybe the radio is just fine, but I need to know that for sure before I put power to it. So the idea is you need to know what the schematic is so you can know how to troubleshoot. But that is a type of troubleshooting, because if you just bought a radio off the internet, you got to troubleshoot that radio. You got to find out, is this radio ready for me to go, or has it got problems with it? And you're going to need this schematic to do it. That's one reason you need a schematic. And then the other reason is part location, because if you're looking at a part on your brand new radio you just brought home, you want to know by looking at the schematic roughly where's that at, where is that. And so roughly, like here, I know that I've got 2 output tubes by looking at the schematic. I know that I've got 2 rectifier tubes by looking at the schematic. And so it helps you to locate parts and what you've got going on there. Then you have the other thing is design understanding. Just like having 2 output tubes, then you know what it is, what they call a push-pull type of radio, and that's a whole different design than a single. If you just had one single output tube, things are handled a lot different. So the reason we need to learn schematics is that. I'll be right back. I got somebody at the door. All right, I'm back. That was a mailman. Bottom line is, those are 3 right now. There's tons of other reasons, but that's the 3 main reasons I want you to be able to learn how to read these schematics, just the basics, so you know what you're dealing with. Because you have to handle your load resistance off of this output transformer different with 1 tube versus 2 tubes on a push-pull. So you have to know those things when you're starting on one of these radios. All right, then why did I go through the things I went through? Why didn't I pick others? There's a ton of other things I could have had videos on, but why did I pick what I picked? Well, the first one I picked was the power supply, because to me, this power supply, you got to have power to a radio before you can do any of this other troubleshooting, because if you don't provide power to this radio, then you can't even turn it on to be able to figure out if there's something wrong with, maybe there's something wrong with a tube or a wire or a coil or a resistor or a capacitor, but you wouldn't know that because you don't have power to it yet. I'll give you a real life example. I'm doing this radio right now. I have to zoom back out. This is for a customer, and this has been one of the hardest radios I've done a lot of hard ones, but this is one of the hardest that I've done. And this radio here has exactly what I'm talking about. It has power issues. When I plugged this radio in, when I first plugged it in, up here on my amps, I was pulling about 1.5 amps, and that's after I did a ton of repairs. You can see I replaced a ton of wiring in here. I did all the recap on it. I got all new caps in. I've got 8, 10 electrolytics in. That's these black caps. I pulled all these panels off, and there's tons of resistors and capacitors up and down each side of both sides of those. I replaced all those. There's probably 30 resistors. I totally replaced the Candome resistor. It has all new sections in here. Trying to figure out why, because when I got the radio, there's a big old resistor right here, and it's a high amp resistor, and it was blowed in half. There was other issues showing that there had been a fire underneath here. So definitely I knew there was going to be a power problem. And the truth is, about 20% of the radios that you do, when you first power them up, you're going to have issues where you have to, your lights will shine up real bright and you think, oh no, and you got to flip your power back down, and you got to get back under here and figure out where is the short at. I will say a lot of those shorts out of that 20%, probably 15 of that percent is go looking in your dial lights up here and your filament section where your low voltage is. Those create major shorts, and they'll keep you from turning the radio on. But the bottom line is, and I don't want to belabor that, but the bottom line is I got this radio to where it's almost, I can turn it on now. I am going to have to step down the voltage, and one of these classes I'll show you guys how to do that. When you come and you put something on right here at the plug, you put something and you can bring your voltage down to where, because some of these radios can't operate on today's voltage where it's 125 volts, and they were designed for 115, so you have to give it a little, I'll say a high wattage, low ohm resistor right here, and what that'll do is step that voltage down. That's what I'm doing. It's like a resistor, like that right there, and I'm putting that resistor in a series with this wire coming in. Actually, it's going to be right before the switch, right in here. I'm going to put it right there, and what that's going to do is it's going to step that voltage down a little bit, so when the transformer sees this, they're not going to see 125 volts, they're going to see about 115. And that's what I'm working on with this particular radio. And I played with it today and got it working. I actually got a radio playing, but I'm still having trouble on the output tubes. I got a good radio playing all the way to right here, but I've got problems here, so I don't know if I've got an output transformer problem or I have tube problem, but I got to work on that. I ran out of time today. But bottom line is we got past the power, so I had to know how to read that power supply on the schematic to know what I was doing, and it has a very difficult power supply. I'll show you that just for the fun of it. This is the actual power supply on that radio, and you can see, I'm going to lay them side by side. You can see quite a big difference between that power supply. It does have it has a double rectifier just like that. But if you notice, there's a lot more windings here than we've got on this side over here, and they have a lot more things that they do. Also, the way it connects to the Candome, if you follow all these lines, there's hardly anything that connects to this Candome over here. And most of the time on these, they'll go straight to the Candome resistor. So, there's a lot of differences in that, and so I have to know how to read a schematic and know how to do that power supply. I'm not going to go too long on that. Then I taught you the power supply so we can get the radio started and get it running. Then we can start checking other things, okay? So then I taught you the wiring part, because then we're going to start, once we get power going to this thing, we know that we're going to have good power going in. Then we have to start checking our wiring. Like I told you before, I start here at the audio and work back. Okay, so you would check each wire and make sure you had continuity like I showed you. And then actually, like I broke it up in parts on this series, but in real life, I would change anything that I ran into that was bad. Remember, we highlighted in green some of these that need to be replaced. Well, I would just fix that as I'm going across. And if there's any bad wiring, even though I have continuity, but some of the wiring is crumbly or whatever, I'm going to replace that as I go across. And I'm going to highlight that when I get it completed, and I'm going to know that I've got that area done. And then I'm going to go on to the next area, and I work from tube to tube. I work from known places. I know where the tubes are, so I can work on each pin of the tube, and I taught you how to read the pin numbers. So you would just start at the tube and work out as far as you can go without getting too far away from your tube. and then you would work across. So I taught you how to trace that wiring. The other thing I taught you about the wiring is distance doesn't matter. If you have a dot at the dot at the end of that resistor right there, let me blow it up a little bit more. Okay, if you have a dot right here at the end of that resistor, and then you got a wire going straight across to that other dot, and then you got another dot that's up to that dot, but this is all straight wire. So really that dot could be, this resistor way over here could be connected to that dot, because electrically they're all connected, so it's all the same point electrically. So you have to put that in your mind, that there is no difference between that wire. The wire can be either short, or it can be either long, or it could be non-existent at all. So you might not even have a wire. Okay, so that's one of the things I definitely wanted you to understand. And then the other thing that I wanted you to understand that I taught you is the audio portion. I taught you how the audio made it to your radio, came to your antenna. I taught you how it flowed through here. And the reason you need to know that is because there's two things. You have RF section, and that's up until you get to right here. And then when you come here and demodulate, you have an AF section. So you'll have audio that goes out here in your amplifier and preamplifier section. So you have radio frequency here, and then you have audio frequency on this end. And I taught you how to do that because when you actually get this thing started and you start testing, and you don't have a radio coming out the other end, just like on the radio I have right now, then you can start tracing, and you can trace across. But now you know how the path flows, because you know how to read that through the schematic, and you see how it goes. It goes from grid on this left side where it goes in on the grid, and then it goes out on the plate. It goes in on the grid, it goes out on the plate. So you can trace your signal right through there, and that's why I taught you that. Okay, and then the last one, of course, was component identification. Remember, I taught you how you can tell, and I gave you two of each kind, two of the resistor types, and there's a bunch more of each one. But the two resistor types was the bias resistor, and then the voltage divider type resistor that gives you different voltages at different spots and different places on different pins. And the resistors, if you have a bunch connected together, they give you a different voltage at each dot. And then the last thing was the capacitor, and I'm going to show you in this one. I taught you about coupling capacitor and then a bypass. A bypass capacitor just allows audio to pass around, so it don't go through the resistor. It goes through the audio can easily go. It's low impedance and go through the capacitor. If you didn't have that there, it would have to go through the resistor, and then that takes away, that resistor is going to mess up, and you're not going to get that good clear sound going through here. So they put a bypass capacitor, allows you to bypass that resistor. So that's a bypass cap. And then you have the cap that's coupling between the high voltage here and the low voltage here, and that allows that AC to go through but not the DC. And to tail into this, I'm going to show you a short little videos that shows you how that capacitor is built and why you want to make sure you check that and make sure you don't have any DC coming off on this side. All right, well, I think that'll do it for this grouping here. This is just a flyover. I'm going to give you one more little thing that I did in this thing, and I wanted you to kind of understand. It's just real basic. Alternating current is just where the current goes above and below that 0 volts. You have positive and then negative. It moves in there. That's called alternating current. Direct current is, you can have direct current. It's just a straight flow of current, say 50 volts, but you could have 50 volts above or 50 volts below. It doesn't have to be, it can be on either side of 0 volts, but it is a solid straight line. It's not alternating above and below that 0 volt line. And then also alternating current can pass through a capacitor and a coil, and then direct current cannot. Alternating current can pass through the capacitor, but direct current cannot. So alternating current can pass through this transformer or this capacitor, but direct current cannot. Those are going to be stoppers for direct current. All right, then the last thing, and I taught you this too, is both alternating current and direct current can exist on the same wire, and they can be doing different things totally. But you can actually flip between alternating current and direct current on your meter, and you can see how much current you've got of each on that particular wire. It helps you troubleshooting. All right, that completes this study. And then next time we get together, we're going to work on to a next thing, and I will bring that up previous to my next video. It's going to be a surprise. Thank you. Okay, I showed a little clip of me heating that end. I heated the end of this up, and then you just grab a hold of it with the pliers. It's hard to do that when you're filming, but I grabbed a hold of that little wire with the pliers, and you pull out the little wax plug that they have in there, and then you can look down inside the end of that, and you can see what we're getting ready to pull out of there. So just a few minutes, I'll pull it out, and I'll come back. All right, here after I heated up the end of that with the heat gun, then you can grab a hold of this. If you're wanting to save the cardboard tube, don't do it the way I did there, but I'm not really wanting to save. I'm just wanting to show you what's inside. But I'm getting ready to pull out this aluminum thing here. Now I can get it with my hands. It's hard to do that holding the camera. But anyway, the plug, you heat it up and the plugs come out the end. And then once you get the plugs out, then you can slide this thing out of the middle. Now, if you don't grab it with a pair of vice grips like I did, you can grab it differently. You won't damage this sleeve. And a lot of guys, they'll take a capacitor and whatever the value of that is. This is a, let's see if I can see it. Well, what do you know? I messed it up right there, but it's a 0.1 microfarad right there. But let's just pretend this is a 0.1. They'll take and they'll slide the replacement inside here and leave it hanging out. Then they'll take brown hot glue and put in each end, and that way it looks like the old resistors or old capacitor is still in there. But actually it's a brand new capacitor, and it'll keep the original look underneath there. So this is just something to think about. If you like that, I don't care. To me, it's all underneath, and I just put them in like that. I take the cardboard away. But I wanted to open one of these up, show you. So I'm going to go away just another minute. I'm going to unroll this. I'm going to show you what it is. Okay, you can unroll this quite a ways, but it has foil on one side and foil on the other side. This is your two plates that are meeting each other, and then they put this paper in between those two, and this is paper impregnated with dielectric stuff, and it has oil to keep that impregnated and fill the pores, or sometimes they'll do wax. But you have this paper in between these two, and so this don't allow direct current. If these two sides were to touch each other, yeah, you could have direct current coming through, and that's what happens. Is this paper starts breaking down and allows the aluminum on this side and the aluminum, and it's just like aluminum foil, but it allows those two to touch each other, and that's how your DC starts coming through. It's where you get direct current through. But right now, it has to be a magnetic field build up on here when you have your current going through this side, and then that magnetic field will transfer itself across, and that's how your audio goes across on here. Your AC goes across, but your DC does not, because the paper's in between. So that's why you end up having to change out these, because you can see how in bad a shape this is. Like, it has all a bunch of broke down pieces. You can roll this out quite a ways. It's rolled up quite a ways, but this is what a wax capacitor looks like in the inside. My mom and dad used to get so mad at me because I would tear stuff up all the time to see how it was made, and just like this, I had to tear stuff up. But this is like the capacitor I'm showing you, that's like on a coupling capacitor between the plate and the grid, so that you don't want that DC getting over on that grid, and so you want to change these wax capacitors out. Now, like I said, if you want to be neat and clean and get this out of here without damaging the case like I just did, that's fine. I throw these away, but you can just restuff them you can slide that new one right inside there and put hot glue, get brown hot glue and put it on the ends, and we'll never know you had a new one in there. This is a big electrolytic, and you can tell that because it has more than one wire going in and out. You have the colored wires that are going to go in, and then your black wire goes out to ground. So it goes into this capacitor, and then it comes out this wire to the ground, so that makes your full connection. And you can tell that there's more than one capacitor in here because you have 2 wires going in, so you have 2 capacitors on here. And you can tell that also by looking on the side of this, and it says 8-8 microfarad at 400 volts. That's working volts. So 8-8 means there's 2 8 microfarad electrolytic capacitors inside here. These are polarized. This kind is not. And I'll go into that later. As you can see, like on this particular capacitor, you have one end of it will say an outside foil. There's a lot of websites out there that go into the how to tell which end is the outside foil, but I will take some time later on. Right now, I don't want to do that in this series. But one end, these are you can put them either way and they'll work. But there is one way that's better than the other. We have reduce your noise when you put it in. So what a lot of people do is they'll test these the way I'm going to show you, but not now. Is they'll test these, and then they put a little dot on the end that's the outside foil, and that way you can put them in here the right direction. Okay, but we'll not worry about that. Now these are polarized. You have to put these in the right direction. If you don't, they're going to blow up on you. And if you ever have one of these big capacitors blow up in your face, it's not fun. I've had a couple that I put in backwards because there's sometimes the schematics get a little confusing on which way that electrolytic goes. And I'll be going into that when we run into that on a radio. I'll explain that to you. There's a little rule of thumb, and once you learn the little rule of thumb, you can put that in the right way every time. But if not, it's going to go pop on you. And a lot of times it's like confetti, only it coming out of a metal case on your replacement electrolytics. You know, they're like this. These are your replacements for that. And that's a 12 microfarad, but it's about the same size. But this is a metal case, and if that thing blows up in your face, you're going to have little shards of metal going all over you too. So you don't want that, all right? So that's all I've got on this. I just wanted to go over that little bit of how a capacitor, why we're changing out that bypass capacitor. And I'm going to go back into my class now. Thanks. I hope you enjoyed the video today. I did it rather quickly, a little quicker than I thought it was going to be, but I think it'll give you a basic idea of what I wanted you to learn on this round through here. Next time when we go through the schematics, we'll be doing it while we're recapping the radio that we bought. So that'll be coming up real soon. I thank you for watching. I hope you like and subscribe. I'm getting all kind of good comments, and I appreciate all those. Thank you guys for making me feel good about what we're doing. I had even somebody say that they bought a Zenith radio so they could follow along, which made me feel really good. That's the end result that I'm after, and I hope all of you do it. But thank you for watching. Bye-bye.